Right, so we want to look at vectors in R. One of the most used data type in R. Very, very important. So let's pay attention. And this is the most comprehensive you can get. And I want to say that before you continue, please subscribe to this channel, share, and allow other people to also subscribe. So, wait, I'm already sharing my screen. I think as you can see, and then we are swinging straight. So, we want to look at vectors. And basically, a vector is simply a data structure that takes a uniform observation. So, we know this. And I've already built the script. I'm just going to explain it quite briefly, and then we are good to go. So let's imagine that I have, so let me work from the console whilst I go up. Let's imagine that I have, what is it, a vector. So I can just put that vector like this way. So I can just maybe have a vector, maybe something like this. And then I want to assign it to a value, like 33. If I run it, yeah, you will see the 33 has been packed into the vector or has been packed into the variable. But when you have more than one, how are you going to do it? That is why vectors come in. So we use a function called combine to be able to combine all the objects, and then we assign it to the vector. So, for instance, if I have, let's say, VTR, and then I can simply use C, which means I want to combine it. I have more than what is it, observation that I have, but there are many. So if I do this, that has also been run. So if I have to build VTR, then you see that the vector has been built. So basically, this is the main idea about vectors, but we will go deeper and understand more and where we are going to be applying them. So to create a vector, there are many ways through which we can do that. Like, what is it? So we can see from here, I can actually create the vector using like the combine function. I can also create it using a function. For instance, let's say I want to create a vector using a function. So the first one, I just created it using, let's say, a combine function. But there are other functions that we can create. The bottom line is that if you have any data variable that is holding observations of uniform or observations which are of uniform characteristics, let's say they are all numbers, they are all characters, they are all booleans, then it becomes a vector. And that is what is important. Now, I can also use a function VTR2, and then I can simply just say, okay, sequence. This is also it's a function. And so I am sequencing from 1 to, let's say, I am sequencing 1 to 100 by, let's say, 10 steps. And then when I do that, so if I print VTR2, I should be able to get, I have done the sequences. So that's a vector I've just created. I can also create a vector of, let's say, a sequence, or I can also use other functions like sample. So I can have my VT3, and then like this, I can have, let's say, I can sample. So what am I sampling? I'm sampling, let's say, from 1 to, let's say, 10. And then how many am I sampling? I am sampling, let's say, 100. That's just a lot anyway. And then with replacement, that should be true because when you are sampling from a smaller population, replacement has to be true. And then that is it. So if I do VT3 like this, I should be able to get my vector all in one. So what is it? All the samples that are used to be able to create our vectors. We can also create vectors of characters, you see. And then let's say I have, if my screen is not seeing, so I can clear the console, I can clear where I'm typing, and then we continue. So let's say I want to create a vector of characters. So there are also inbuilt functions which is there. So let's say I have VTR underscore C, which means a vector of characters. And then I'm just going to say letters. So this particular function, uh, what is it? Actually allows us to be able to build letters. So that is alphabet. So if we run that, So if I have to say VTR underscore C like this, I should be able to get my alphabet. I could do the same thing with, let's say, VTR, that's my vector of, I'll put it underscore M, which means month. So if I come here, I can just say month dots. So do I want the full names, or I want maybe I want the abbreviations? And so I can simply run that. So if I put VTR underscore M, and then I run it, you should be able to see January all the way to December. These are the various ways through which we can build our vectors, and then they're all sitting down there. So let's look at the next thing to do about vectors. After we have created the vectors, there are some things, there are some few things that we can do. So let's say the vectors I've just created this morning. Let's say I want to check the length of the vector. So how many observations, or how many elements is the vector holding? But the word element, we don't use it. We use it when we are dealing with lists. So how many observations is the vector holding? So we use the length function. So I'm simply going to say, so I already have um, the length function. So I'm going to say length. So the length function comes. So I'll just put one of the vectors there. So I have VGR underscore M, and then you run it. It tells you there are 12. Actually, there are 12 months in a year. So we've checked the length. We can actually check the class of the vector. So we come here and we can say VTR3, and then run that. It tells that it's an integer. So it tells you what it is. So let's look at the structure. Obviously, here is not too much needed, but we can just okay, and check. So we say it is a number made from 1 to 6, as you can see underlined around here. So that is how we do it. Let's go into, let me run console again, and let's look at something. Checking the class, how do we reverse a vector? Now, when we have a vector, let's say I have VTR underscore the character here. What is it? We had alphabet. All right. So we want, so if I have the vector VTR underscore something like this. So if I put this is called index notation. This is what we used to be able to sample. I'll get to that. So if I put here 1, it will print the first one. So if I put there 26, it should be able to print the Z for me. So if I want to print from Z all the way to A, it's a matter of me, or let me put this before. What about if I want to print, let's say, 1, if I say 1 is to 20, it will print all, it won't print all the alphabet, it ends at T. So which means that those ones are index positions. So it's a matter of inversing the index positions. Let's say, so if I say 26 all the way to 1, then it will inverse it, start from Z, and that's how we inverse what a vector. It's just simple. So we could also change the length of a vector. So how do we change the length of a vector? It's simple. We've already got the vectors now, so I am just going to be the length simply means that we can, so I have VTR underscore, let's say the characters here. So we want to change the length. What we can simply do is we can repeat the vector, right? So I can simply repeat the vector and come here and use the repeat function, and then I'll just close it. What am I repeating? I am repeating this particular vector by, sometimes if you don't put it, it will assume that you are repeating it just twice. But we can put times there, add this particular argument. I think I needed to close it, close the bracket so that it will see it as a function. And so if okay, right. So let me start it over again. So we have the repeats, and so we have VTR underscore C, this one. And so we are saying that times should be a function, and we are repeating it twice. Let me see. And so you see that it has repeated it, but it has repeated it. It will start from the first one up to, you can do that if you want it to be done 3 times, 4 times, and then in that order, which means it will print the first vector, finish, come and print the second vector. So let's look at another way. We could have also done this and say each, right? And then each means we give it 2. So, or let's this time I'll give it 3, which means that every single observation of the vector would be printed 3 times. And that's what we've done here. So you see that A, B, 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 C, 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 then in that order. So that is how we can increase the length of a vector. Then we can repeat it. We can repeat each time. So, okay, we can also delete some elements of the vector. All right. So let's say that let's say we can do some element. So, but a variable, another vector, and let it be sitting there. I'll use it for something else. So I'm just going to put this. I'll just do right assignment, and I'll call this vector repeats underscore repeats, and then I'll just run it. So I'll keep it as I've saved it in the memory. Now let's look at how to delete some element of a vector. So we've already got this vector of characters, which is here. So vector of characters, which is there. So let's see, how do we delete some element there? If I have, if I run it, it's fine. You can see it here. So I want to delete A, B, C, D. So if I put index function like this, and I put 1 is to 4, that will print A, B, C, D, right? So now, if I use the same thing, and I come to this place and put here minus, come there, put minus, it means I'm saying that I want to take A, B, C, D out. So for minus 1, 2, so you see that it doesn't print, it will print the rest and leaving only minus this. There are other way of doing it. You could also have left the minus like this, and then you simply use combine function. But before the combine function, you have your minus, and then you close this up. It's the same. It will still give you the same thing, and that is how we are able to delete some element. You can delete them the way you want. Then we can add elements to the vector as well. So let's say that the vector has some element on some element that come to maintain this particular same vector so that the understanding will flow. I'm going to come here and look at this. We have a vector of characters, or let's say this. Now let's use the month. And then we want to increase the length. We know a month, we have 12 months in a year, right? So if I have the vector like this and I have this, so if I say print 1, it will print January. If I say print 12, it will print December. But if I say 13, it will print now. It will tell you it is not available, right? It means that's a space we can actually create and then add what is it, 1 or 2 things. So now let's say that I have it this way, and then I want to create some spaces. So I can say from 13 to 15. So it will tell me that those ones are not around, but 3 vacancies are there with are none available. There's no data there. So what I can simply say is I have that, and then those places that are available, I can just assign some values to go and occupy. How many spaces are available? 3. So I want to assign values. Where am I getting the values from? I could just say I could use the same function like month dot app. This time around, I want to say name. I want the full name so that you can see the distinction. But this time around, I'm looking for just 3 of them. So I will say 1 is to 3. So I'm taking January, February, and March, and then adding it to that. So when I do that, and I now print my vector vt underscore m, which is here, you should now see that some January, February, March has been added to it. So this is how we increase, or this is how we make sure that we increase the length of a vector, or adding elements. That's how we add elements to a vector. We can do this different ways, and then you just need to select the positions. Now, application of statistics in vector. I think this is not too much of a problem, but let me just run through a few of them. So you can actually multiply, you can add, you can subtract, and then all of that. So the vectors I have, let me check. I started with VTR. I don't know which of them had more values. Okay, this one had a lot of values, right? So, or let's create a new vector and work with it just outrightly. So I'm going to say, what is it to do? What is it? VTR underscore like tutorial vector. And then I'm just going to create, or I'm just going to say that I want sequence. I want to sequence some few, yeah. And then I am sequencing from, let's say, 1 to let's say 40. Sorry. Oh, okay. 1 to 40, and then by 4. Or no, let's say by 5. I want to have it. And so we do that. So if I have VTR underscore T, then we should be able to have this 164. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8. We could have used len to just count it. I think we should change it to about 3 so that we can have more values to be able to make sense. So I'm just going to come here, run it again, and go back to the vector again, run. So the length has increased. So we now come and then we look at the maximum. What is the maximum value of that particular? So you just have to do your max like this, and then it will give you the maximum, and then you put the vector name inside. It's going to give you the maximum. So we have VTR underscore T, and then when I do that, they say the maximum number is 40. Now we could also check for mean, and so I'm just going to come here. This time I'll be changing only this, and so I'm just going to write the mean, and then that is going to mean, and then that should give me 20.5. That's the mean. We could also check for median really quick, and then our median should practically be very close to the mean. We could also check for other things like variance, the variance which is there. So you just need to put var. Var means variance. Variance of 56. When we count in R, standard deviation is SD, and then that should give us 12.45. So what again, we could check for percentiles, or we could just check absolute. Let's say we had negative numbers. We could have just say we want to have absolute. So I have ASE, then you see we don't have any negative, so it will print the same vector for us. If we had negative numbers, it would have taken those ones out. And that's what we're saying. So finding the normal distribution of a vector. Mostly the vectors come with very varying, the variation between the objects or the observations are too wide. So you want to normalize your data. So you can actually say R norm, so which comes, and then you put a vector there, VTR underscore T, and then it will give you the normal distribution, right? So we can see the normal distribution, which is now here. So if you want to get the difference here, if you plot, if you give, if you do a histogram of the original vector, and then this that of the normal distribution, see that the normal distribution will give you actual normal distribution shape. Maybe you have to try that and for you to see before we continue. So I'm just clearing. So let's say I want to so of the VT underscore T and then run that. So if you can see the you see the vector is here. You notice bell shape. So now let's say I have a histogram, the same histogram, but this time around norm VTR underscore T, and then so two normally distributed. But that's how the data is. We normalize this a little bit. So that is how we do this. So let me close this one up. We don't need the plot set for now. So we could also find quantiles. Quantiles means you want to know uh, the the minimum, the maximum, the third quartile, first quartile, and all those things. So we use the function called quantile. Quantile which is there, you just put the vector vtr underscore t like this, and then that should give us. So you can see we have our 0%, 25%, 50%, and then all. So we could also look at ceiling, that is basically to make sure that we have only whole numbers. You notice that when we ran the normal distribution, we had a lot of decimals like this. So what ceiling? Ceiling. I hope I got the spelling right. So if we come to this side, you just close the bracket again. So here it now gives you only whole numbers. You don't have, and that's what we do. We could also do round to. Then you specify the. So I could have just come here instead of the ceiling. We use round to. So we have round, and then for round, we are rounding it to what? So you just simply come here, put, and then we have, let's say, 2 decimal places, so that everything will have 2 decimal places. And this is how it works. So you have to pause the video wherever you are not getting it. So we can round, we can introduce decimals to our vector. You notice the vector initially didn't have decimals, right? So for instance, vtr underscore t, it did not have vectors, decimals. Now we want to introduce decimal, just add some maybe 0.001 or something. So I can just do that and say 0.0, sorry about that, 0.001, and then we've introduced decimals like that. So we can also inverse the vector. To inverse vector simply means that multiply by negative. So I'm going to say multiply by minus, let's say 1. All of them will now be negative numbers. We've inversed it. We can arrange the vector in order. We can arrange it in order. So we use it, we say sort, the sort function, and then we put your vtr underscore t, and then it is arranged in order. Then what about if we, okay, substituting elements of a vector, very important. How do we substitute the element of a vector? If you have some little code, so and you want to substitute. So now let me pick a different vector that we have built so far. So here we have all this up to Z. Let's say you want to substitute A, B, C, right, with something. So I can just have the vector like this, then specify their positions. Let's say ABC is 1 to 2 to 3. So I'm just going to say 1 is 2, 3. What are you substituting it with? So you assign that in 1 and 2 with, where maybe we're substituting it with only A. And then when we do that, now when we print we should see only A. And then because we substitute with only 1. Sometimes we can also substitute with, let's say, different, maybe a vector or something, and then in that order. So we can substitute the first 4 elements with different vector. So let's say we come here. So we could have substituted the first 4 elements, and then we are good to go. I have some crazy what is this kata that is worrying me, but I'm fine. So here we could have just do this, then have a vector like this, and then I could say come here, and then we have again, because we are substituting their characters, so I can just say BB, I can then I can just say, let's say Brenda. Okay, so now when we print the vector, we should be able to see those substitutions. That is how we are able to substitute. So we can continue. There are other ways of substituting, and then as you can pause the video and have a look at the script that I've already written. We can swap some elements of the vector. We can check to find out. So if the vector has, let's say, some NA, so we say dot NA, and then in that order. So these are basically how we deal with. So I'm going to scroll quite slowly. You can pause the video, check the heading, and then how you can multiply a vector by a vector. You can divide vector by vector, then in that order. You can have modulus, you can exponent a vector, Then you can take a log file of all the vector. You can find out if numbers is in the vector or in the, and then you can also visualize the vector. And like I have already done here, showing you can plot the vector and then you are good to go. So thank you. This is how we deal with vectors. Watch out for the next video. We're looking at data frames. Thank you, and I'll see you some other time. Bye-bye.